Hello everybody and welcome to your Chem 113 review on atomic mass of isotopes. My name is Jason and I work for the ASU Tutoring Centers. So the idea here is the isotopes of an element that occur naturally in the world, there's not necessarily one that occurs all the time. There's usually different isotopes that occur at different percentages. So what happens is, scientists, if they want to find the average atomic mass of chlorine, they'll just start isolating a bunch of different chlorine molecules, or chlorine atoms, I suppose. So they'll isolate them and find what their atomic mass is. They look at the number of neutrons they have, they may weigh the chlorine in some way to find what the mass of that chlorine is. Some chlorine, like for instance this one, might occur more frequently than this isotope of chlorine. Okay, so it's saying that after doing test after test after test after test, scientists have determined that 75.78% of all the chlorine that occurs is chlorine 35, or chlorine with this atomic mass. Whereas 24.22% of all the chlorine that occurs in the world is chlorine 37 with an atomic mass of this. So keep in mind, although this is chlorine 35, right, which means that it should have an atomic mass of 35, it actually has an atomic mass of 34.969. And this goes back to that whole accuracy thing that we were talking about. They did the experiment after experiment after experiment, and the average mass of chlorine 35 was actually 34.969. So it's really close, but it's not the exact value that it should theoretically be. And same thing here, they did experiment after experiment after experiment using chlorine 37, and they found that its atomic mass was on average 36.966 AMU, which is atomic mass units. Okay, so again, they're close, but they're not exactly there. So then using these values, the average mass and percentage of chlorine 35 and average mass and percentage of chlorine 37, can we find the average atomic mass for chlorine in general? If we were to just take a random chlorine molecule from anywhere in the world and say, what is its atomic mass going to be, we can kind of guess, right? That's essentially what this is. We're finding the average atomic mass of all the chlorines across all of the different isotopes of chlorine that there are. So how we do this is we take the percentage of a particular chlorine isotope and we multiply it by the mass. Okay? It's very similar to, imagine you're like rolling a dice and you want to find what the average roll is going to be. Well, if you're rolling a 6-sided dice, the numbers 1, 2, 3, 4, 5, and 6 all have a 1/6 chance of occurring. So if you wanted to find the average, you would take the value times the percent that the chance that it occurs, 1 in 6. And you would add up all of these values. And when doing so, you get 3.5. Which means that if you roll a dice, on average, the value you will get is 3.5. Now, a dice doesn't have the value 3.5 on it, but it's saying that if you were to do experiment after experiment after experiment, if you rolled the dice 1,000,000 times and then found the average of all of those rolls, your average is going to be about 3.5. So we can apply this similar idea for the average mass of chlorine. So what you do is you take the percentage that an isotope occurs, write it as a decimal, so 0.7578, and multiply it by the mass of that isotope. And we would do that for every isotope we have. So we also have an isotope of chlorine 37. So we would multiply and add them all up. I should put the AMU units here. And when we do that, we get 35.45 AMU. So that's the average atomic mass of chlorine out in the entire world. If we were to take an arbitrary atom of chlorine from somewhere in the world, on average, its mass will be 35.45 AMU. And hopefully that makes a little bit of sense, right? This chlorine 35 molecule occurs way more frequently, 75% of the time, than this chlorine isotope. So our average should skew closer to chlorine 35 than it does to chlorine 37, just because the chlorine 35 occurs more often. And our number we get is 35.45, which is definitely closer to 35 than it is to 37. So it makes sense. Our average is skewed in the direction that we think it should be skewed in. Okay, so that's how you find average atomic mass. You take the atomic mass of an isotope, multiply by its percentage, do that for every single isotope and add them all up. That gives you the average atomic mass of your element. Thank you. Thank you for watching. As I mentioned at the beginning, I work for the ASU Tutoring Centers. If you want to see what free resources we have available on all 4 major ASU campuses and online, please check out tutoring.asu.edu. If you want to see more videos like this that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for the exams in your course, go ahead and check out that link below. Thank you all for watching, and I hope you have a wonderful day.